In section 2, we're going to learn more about linear functions. Look at the equation. You probably recognize this from prior algebra classes, and it's on the formula sheet, so you don't have to memorize it. You just don't say a whole lot about it on the formula sheet, so make sure you know the ins and outs of the formula. This is called the slope-intercept formula because the number in front of the x is the slope, and the number out at the end is the y-intercept. So when we see an equation like y equals 3x plus 7, we immediately can recognize it has a slope of 3 and a y-intercept of 7. Here's some others. Can you recognize the slope and the y-intercept? And this one. So that's a handy formula to know and be able to understand. What's really handy about it is being able to draw graphs so quickly and easily. If I have a linear equation like y equals 2/3 x minus 3, immediately I know that there's a dot at -3 on the y-axis, and I can count from that dot up 2 and to the right 3. And there's the graph. So we should be able to graph things like this very quickly and easily. Now, the rest of this section we're going to spend trying to come up with equations if we know something about the lines. Now, the key to this is to have an equation that's usable for doing this process. And this is the one that's on the formula sheet. It's called the point-slope form for the equation of a line. Let me explain. The x and the y in this formula remain x's and y's. You do not change them or substitute for them. The x with a little 1 and the y with a little 1 mean some numbers. We'll see what those are in just a moment. And the m is a number. So our task is to come up with the numbers. Now the slope, says right here in the problem, is a 4, and the point is a -1, 3. So if we substitute those in, we get this equation. Now, even though that is a sufficient equation, we usually change the looks of it a little bit. And so x minus -1 is x plus 1, and 4 times x plus 1 would be 4x plus 4. Adding 3 to both sides, we get 4x plus 7. And so this is how we go about finding the equations of lines. Now here's another problem where we're asked to find the equation of a line that's parallel to this one. Now, if you recall, in the last section we talked about the parallel and what it means. But we start off by looking up the formula from our formula sheet and recognizing what is the x1 and the y1. That's the point, 2, -1. And the word parallel means m is going to be the same as the m in this one. And so m would be a 2. Substituting those in and simplifying, we get the equation of the line. Now here's another one. The terminology has changed a little bit. Technique is basically the same. Take the equation off the formula sheet. Recognize the x1 and the y1 means the point. And this time the word perpendicular means we take the slope of this one, 2, do the negative and the reciprocal. Plugging those in and simplifying.